Okay, so this lesson, we're going to call 7.1, is on the Pythagorean theorem. I think this is review. I'm hoping most of it. All right, we are going to add a little part at the end on how we check for the converse, which means we can tell if a triangle is right, obtuse, or acute. All right, so let's try to get going here. All right, so the first one is Pythagorean theorem is used to find the missing side. And the other key word here of a right triangle. So it has to be a right triangle for a Pythagorean theorem to work. So we're going to give you some other things later on in this section. This is our trigonometry section where we can deal with non-right triangles, but we're going to stick with right triangles for the first couple sections here. So A and B are called legs. Okay, so they are interchangeable. So A, B are interchangeable. C is called the hypotenuse. And the hypotenuse has a special place, right? It has to be in a particular spot. Again, the other two are interchangeable. If we use A's, B's, and C's, it's A squared plus B squared equals C squared. That might look familiar. We've been using that already as our distance formula, okay? Because it really finds diagonal distance on a graph. All right, so let's do the first one here. Okay, if we look at number one, if I have it, it's the two legs. So this one goes together pretty easily. 8 squared plus 13 squared equals x squared. Okay, now what we could do as a shortcut is you could just start with the square root of that. But if I add those two up, I'm going to get 233 equals x squared. And then if you take the square root, you get the square root of 233. We're going to allow you to use decimals, at least one decimal place. That's going to be about 15.3. Okay, so this is a common one here. It's really your distance formula if you want. I know the horizontal and vertical distance for that one. Okay, now if I go on to another one here, and let's look at number 4. Number 4, I just want to remind you when these come up, that's not always the two numbers, because look what they give you here. They give you these two. This is the hypotenuse, which means it has to go on the other side. That requires some subtraction. So the way this is going to set up then is I get 19.1 squared plus x squared equals 30.5 squared. So again, a common error for students is they just take the two numbers and put them on the left. That is not always the case. So not too hard though. I just got a little bit of arithmetic before I take the square root. So I have 364.81 plus x squared equals 930.25. Some pretty big numbers. I'm going to subtract 364.81, right? 364.81. And then just a reminder, you have to get x squared by itself before you take the square root. So when I do that, I get 565.44, which results in 23.8 when you take the square root. Okay, so again, you're not taking the square root until this x squared is all alone. That's on the last step. Okay. All right, so let's look then down here. Some other interesting ones. Let's look at number 5. Number 5 requires us to know something about isosceles triangles, if you remember. So, because we have a part that's missing, if isosceles triangles, if you remember, this angle is equal to this angle, and this side's equal to that side. Angle, if you want. Okay, so if I have that, and this whole length's 22, there, can you see that this is 11 and 11? So I do expect you to know that I bisects that line. There's a lot of geometry in that. So once I figure out that, this is your hypotenuse, this is one of the legs, I'm trying to find the other one. So this one sets up again, it's going to be 11 squared plus x squared equals 24 squared. A reminder that the legs are interchangeable, so you could flip them around if you want. I would get 121 plus x squared equals 576. Subtract, I get x squared equals 455. And then I finally take the square root to one decimal place, I get 21.3. Okay, so a little bit of our isosceles memory there for that one. Let's look at number 6 quick. Number 6 is a trapezoid, which we'll learn about. In order to do this one, what you're going to do is drop a construction line here as a hint. And then if you know how rectangles work, it's a little ahead of us, so I'm not going to spend a lot of time on it. But this is how you would rewrite this, creating a right triangle right there, is how you would do it. And then I guess, just let me go over it. This is the side that's missing. Are we good enough logically to say if that whole side's 18 and this is 5. How would I find this missing part? I would take 18 minus 5, giving me 13 there. Okay, so a little bit of construction. We'll talk about that later. All right, let's look at number 8. Number 8 is a question where it shares a side. Okay, so this one's a little tricky because you do have to find this side before you find x. Okay, so just to want to go over one of those problems where you have to add a letter. So if I add that, right, to find y, I would have 10 squared plus y squared to find the shared side equals 25 squared. That would be 100 plus y squared equals 625. I subtract 100, I would get 525, and take the square root. That would tell me y equals 22.9. So again, that doesn't tell you to do that, but that's what you got to do. Then I have a second part to the problem where now that I know that, I know I have 22.9 squared plus x squared equals 28 squared. So a little bit longer, a little bit trickier here. So what I would get is I'd get 524.41 plus x squared equals some number 784, I think it turns out to be. If I subtract, I get x squared, I think equals 259.6-ish. And if I take the square root, I get an x value of 16.1. So I'm sort of less interested in the arithmetic and the algebra, and more interested that you know for this particular problem, you have to create your own problem there and figure out that distance. All right, let's look at number 9. Number 9, another trapezoid. This is a little bit trickier because what they want you to find is this height. Okay, now this slash and this slash, hopefully that tells you this is 20. I'm missing this right here. So what would that be? Well, if you think about it here, if this is 26 up here, okay, if this is 26 of it, and this whole length is 40, and this is congruent to this, that tells you this angle is congruent to this angle, that tells you this side is congruent to this side, which means I can divide that by 2. So the way that you find this missing slot here is you would take 40 minus 26, right, which would give you 14, and then because it's divided equally, you would take 14 divided by 2 and get 7 here and 7 there. And then again, I won't waste time doing that, but then you can do Pythagorean theorem. So again, a little bit of what we did before. Yeah, that's what we would have. All right, so let's look at the setups for these next ones here. There's some applications, some word problems. I want to look at 11 and 12. So number 11 uses the word diagonal. So I just want to go over this one. I'm not sure if you're familiar with what that is. But I have a rectangular deck. So if I draw my rectangle, okay, I need you to know the diagonal goes across like this. That's probably pretty obvious. But it says if the dimensions are 10 by 23, what is the length of the diagonal? So that would be the setup for that. Again, just to save us some time, what would that look like? It would be some version of 10 squared plus 23 squared equals x squared. I'm assuming kind of by now we will be able to put that together. The other one we'll go over is number 12. Do we know our north, right? You know this, east to the right, west? If you think of the United States in your head, I don't know if anybody does that anymore. Okay, that's how that works. So whenever you have east and west and directionals like that, there's a right triangle. So if she dropped 3.4 miles east, then 5.7 miles south, sort of linked on right, because it went there and then to here, how far is she away from her starting point? This would be the setup for that. Okay, so I just wanted to go over a setup for that in case you run into one of those. What's the setup again? 3.4 squared plus 5.7 squared equals x squared. I don't want to lull you to sleep. Make sure you're checking that these are the legs and that the hypotenuse by itself, those two just happen to be the same. Okay? All right. When you have the hypotenuse, the most common ones are a support wire that runs to the ground, and up here is the other most common one is a ladder, okay, where that's going to be the hypotenuse, where they give that to you. So for instance, this one, I guess I can set up real quick. If the ladder is 5 feet from the house and it's 16, and I want to find this height, do you know that it would be this then again? Okay. Where? Not the same, sorry. All right, let's look down here at the converse then. Now we can use Pythagorean theorem then to find out whether I have an acute right or obtuse triangle. And here's how it works. I'm going to compare Pythagorean theorem. If c squared equals a squared plus b squared, that means the Pythagorean theorem works. The only triangle that works for is a right triangle. Now, this is pretty easy to remember, I think. If I use these to check, if c squared is greater than a squared plus b squared, it is not a right triangle. And what I like about it is greater than relates to obtuse. I think maybe you can make a connection in your brain to put that together because obtuse is bigger than 90. And then I will check if c squared is less than a squared plus b squared. Again, not a right triangle. It's going to be acute. Okay? All right, so let's do a couple of these. The first thing we're going to do is check whether it is a triangle. And then if it is, we're going to use that to check and then identify it as a right obtuse or acute triangle. So for the first one here, let's look at number 1. Okay, first let's check. So how do you check? If you remember, you take the smallest sides, right? 3 plus 7 equals 10. That's greater than 9, so it is a triangle. Okay, now what we're going to do here is which side is the hypotenuse? Well, the longest side is always the hypotenuse, okay, in a triangle. We're going to compare it to that one, okay? So the longest side you're going to do, all right? And then, well, that's the only one that has a chance to be the hypotenuse, could be longest. And then the legs can go on the other side interchangeable. So what I could do here is I would take 9 squared, and then over here I would check 3 squared plus 7 squared and compare them. So this would give you 81, this would give you 9 plus 49, and this would give you 81 compared to 58. So do you see that the c squared, if you want, the longest side there, is greater than the two things, so that makes it obtuse. All right, let's look at number 2. I have these. Okay, again, I'm going to take the longest side and compare that, and then I'm going to compare that to the sum of the two smaller sides. If I do that, 29 squared turns out to be 841. This over here also turns out to be 841. What that means is this Pythagorean theorem works for these three. That makes it something we call a Pythagorean triple, and that has to be a right triangle because Pythagorean theorem works, or they're equal to each other. All right, let's look at number 4. Oh, I didn't check, by the way. If you add these two up, that's the first thing you should do, obviously bigger than 29. So let's check number 4. Number 4, first thing to check, does 17 plus 17, is it bigger than 22? Is everybody okay if I don't add those? That's true. So it is a triangle. That's a triangle. So then what I'm going to do is take the longest side here, 22 squared, okay, and compare that to 17 squared plus 17 squared. This is going to give me 484. This is going to give me 289 plus 289. If you can do it on the calculator, you can trust me, it turns out to be 578. That means it's less than. So what does that mean? It is a triangle. It's not a right triangle because it's not equal, and it is acute. All right, last one here. Let's see number 6 for your notes. First thing I got to do is compare these two. All right, if you take 15 plus 8, you get 23. What does that mean? That means 23 is not greater than 23. So I can cease that one right away because it's not a triangle. Okay, so just to review Pythagorean theorem, a little bit of the setup, a little bit of word problems, and a little bit of what we call the converse. And we'll go over more examples.